I need you to understand what's coming up. You have quiz corrections that can be turned in tomorrow. You have worksheet corrections that can be turned in next Tuesday.
Yeah.
So I gave them back to you yesterday. Okay. Now, on Monday is our test. Okay. So today is the last day of new material, and we will spend Thursday and Friday reviewing for our Monday test. It will be great. Okay, so here's my suggestion. We will spend Thursday and Friday reviewing, but like those of you who have flex, you should redo problems on your review on Monday during flex. Or if you don't have flex, just when you get to school, review your math review a little bit before school starts. No, but I had to. Seriously? Do you listen? Like somebody just asked me that.
It doesn't go back.
Okay. All right. So we are going to talk about today something called a sequence. Okay. Okay. So first of all, up here, I want you to write that a sequence is a list of numbers. Yes. That follow a pattern. Okay. So a list of numbers: 1, 1, 2, 3, 5, 8, 11. They follow a pattern. Like we didn't spend a whole day on this.
Oh yeah, that makes sense. Ah, I get it. Not the sequence itself, but it was just like repeating itself over and over. Because it was like science was math, English was math, social studies was math, then math was math. Giving me so hard. Oh yeah, that day.
That was very hurtful. I put a lot of work into that day. Thank you. Okay. So we have something called a geometric sequence and something called an arithmetic. Sequence. Can we all stay in our seats? This is super annoying. No, sit down. You can turn that in later. Have you had Mr. Barnett's class today? It shows. You'll understand after 9th hour. Yep. Okay, so in an arithmetic sequence, we have a list of numbers with a common difference. What the heck does that mean? What do you think, Henry?
Like addition, subtraction?
Yes. When we talk about a common difference, we are going to add and subtract or subtract the same number over and over and over. How was an 8? Which one did you take? How long did you just finish? Sorry. I'm eating a Jolly Rancher to help my throat.
You sure? I think if one person is on
Okay, the other day I bought you like 100 Skittles to share between the two of you, so.
You don't like any candy. I don't like any.
What? Okay. So this sequence, 2, 4, 6, 8, 10, 12. This is what's called an arithmetic sequence. Why?
Because it's adding on to every time.
Okay, we have a pattern of adding or subtracting the same number between every term. So notice how we are plus 2, plus 2, plus 2, etc., etc. Also, this is a arithmetic sequence. Why?
It's minusing 4 every time.
We are minusing 4 every time. Okay, so if you were to use an educated guess, an arithmetic sequence, we are adding or subtracting the same number over and over. What do you think geometric sequences? Okay. So a geometric sequence is a list of numbers with a common ratio. And what that common ratio means is that, hey, we are multiplying or dividing the same number over and over and over. And so 2, 4, 8, 16, 32. This is an example of a geometric sequence. What would our common ratio be? We are multiplying by 2 from term to term. So if I take 32 over 16, we get a ratio of 2 over 1. If I take 16 divided by 8, we get a ratio of 2 over 1. My desk is kind of a mess.
I'm not organized during advisory anymore. Yeah, please take it. Please take it. I would really appreciate it. I want to go.
Which one are you?
He never lets me leave.
What did you just say, Connor?
I didn't say anything. That wasn't me.
What do you think he said?
I heard that too. Except you. Oh.
Yeah,
No, I didn't. What?
you literally said people, but actually said it.
I think that was. He was making scary. Wow.
Hey, we use it appropriately. Can we not make fun of people?
It wasn't even me. It was.
No one, Joe.
It was Matt. It was
You a big fan for this?
All right, so look here.
Real. He never lets me take this class. Take her. All class. Why are you listening?
I'm waiting for you.
I cannot hear her.
I'm waiting for you. Okay, notice how in this sequence, 1, 5, 25, 1, 25, our common ratio is 5 because we're multiplying by 5 over and over and over. Now, what if I wrote 100, 50, 25, 12.5, yada, yada, yada. How about you write it down also?
4. 2. Divided by 2. Yeah.
We can just find the page.
Okay. Do you agree that we're dividing by 2? Okay. So instead of saying dividing by 2, we are going to say we're multiplying by 1/2 from term to term. So our common ratio would be 1/2 since we're dividing by 2. Okay. Yep. Okay, go to the next page, please. What are you doing? Can you just put it down? Thank you.
Answer Goro. Yeah, answer Goro. You know what Randy is?
Yeah, random integer.
Is it actually?
Yes.
So why does it, when I put 1 + 1, it just says 8?
That's not what you put in it.
How would you use Randy?
For another day, Brooks. For another day.
I guess my
Okay.
Where's Randy?
I mean, you can't get that one.
I would like you to look at number 1. And I would like you to think about the pattern in number 1. Drew, what do you think about the pattern in number 1? With a question mark in her voice, she says we're multiplying by -4. Is that what's happening? Is that what's happening? So we have a geometric sequence where our common ratio is -4. Put the calculators down. Okay, let's look at number 2. What do you notice about the numbers in number 2, Kari? So +4, +4, +4. So what kind of sequence is this? Arithmetic. Arithmetic sequences have common differences. In this case, our common difference is 4. One number 3, DJ. So you're saying 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 32.
No.
This times 4, right? That's not consistent, is it?
Is it no?
Neither. Oh,
Is it no?
Neither. There's no pattern. You and your elbow partner are going to determine 4, 5, and 6. Get started.
You go on. Yeah, what are you doing? Hold up. A, B, C, D, E, 4. Seeing geometric. Doesn't abstract mean make no sense?
No, it's more of a
Not
yet.
Huh?
All right, here we go. Let's chat. Okay.
Do it around.
Just lift it up.
He's moving. I got it.
Okay. Number 4. Gabe, what do you think about number 4? But why? Okay, we don't have a consistent pattern. Darn it. Allison, what about number 5? Okay, so Allison says this is geometric. Noah, why is it geometric? So our common ratio is 3. Can't believe that. Let me. Why did you say no? Okay. No, it's fine. Is there a misconception or you just said the wrong word? All right. Number 6, DJ. Carly, why does he say arithmetic? Okay, we are adding 8 every time. So we have a common difference of 8. All right, now the next thing we need to be able to do is figure out, okay, is it geometric? Is it arithmetic? And depending on what it is, we want the next 3 terms. So, Noah, Mr. Bossy Boss here, what kind of pattern do we have going on? We have times 3, is that what you said? Okay, so we have geometric. Brooks, is he right? Times 3? Okay, so help me out. If we take 189 times 3, $567. Can somebody please confirm that? Okay, now take that times 3.
1701. And then that is 50. Yeah, what did you say, 50? Sure.
Like that?
Yeah.
Okay, so these are the next three terms. We have a geometric pattern. So we're going to use that pattern and multiply by 3 every time. Okay, if you're using your calculator to multiply by 3, that is an appropriate use of your time. If you're just playing around with your calculator, that is not what I'm asking you to do. Let's look at number 8. Okay, DJ, I know you know. I know you know. Henry, what kind of pattern do we have?
Dividing by 2 to geometric.
Okay.
It's multiplying by 1.
We're dividing by 2, which is the same thing as multiplying by 1/2. Can everybody agree that that's the pattern? Okay, so technically our common ratio is 1/2, but yes, it's the same thing as dividing by 2. Ginkle, what's 72 divided by 2? And Reese, if we divide that by 2. And everybody, if we divide that by 2. That was the lamest 9 I've ever heard. 9. All right, what's happening here?
Multiplying by -2, so geometric.
Ooh, we have a pattern that is geometric where we are multiplying by a -2. So do you notice that when we multiply by a negative number, our sign, positive, negative, flips back and forth? Do you notice that? Okay. So after -40, what would our next term be? Positive 80. And after that, we would have -160. And after that, sometimes we get excited. It's fine. So what I want you to do is go to number 10, and I want you to write the next 3 terms and stop. What? 5/4? 5/4. 0.125? 1/8? Isn't it? Yeah. I'm gonna tell you how to graph it. Okay, this one has fractions. Oh man. Corey, what's the pattern from term to term?
1/2.
Okay, we're multiplying by 1/2. So Connor, if we multiply 3/2 by 1/2, what's our next term? 3/4. And if we multiply that by 1/2, Kyron, what's our next term?
3/8.
And if we multiply that by 1/2, Harry, what's our next term?
3/16.
Okay. So, Ms. Holman, how do we graph this? I want you to do that. Label the y, the x coordinate 1 through 8. Label the y coordinates by 2. That's a lot. You don't know what you're doing.
Huh? Oh.
Okay, so to graph a sequence, this is what you're gonna do. Do you see how our first term is 12? So we're gonna go first term is 12. Our second term is 6. So our second term is 6. Our third term is 3. Our fourth term is 3 halves. Okay, what does that look like?
A downward slope.
It does not look like slope, no.
Negative correlation.
Oh, what's the word? It's the.
Yeah, exponential decay.
Yeah, I knew that.
If we graph this one right here, where our common ratio is 4, it would look like exponential growth. What would an arithmetic sequence look like?
Linear.
Yes, Ellery. Eli is not going to corroborate your story. No.